Hello, it's Peter
Darek.
and welcome to the fourth episode of Distributed .NET Core course. And today we'll talk about the events, right?
Yeah, and internal communication between the services in general.
Yeah, so let's get into the code right away. And yeah, recently we created a handler for our create discount command, right? So we added the RabbitMQ message bus, and now we are able to subscribe to this particular message being sent through the bus, which is here. And we have our handler that can consume this command and do some internal business logic. And let's think about what's happening, what should happen next, right? Because here we created our discount, we stored it into our database, but we might want to notify the other parts of our distributed application that something happened. And this is where we make use of the events, right?
Yes.
Okay, so the idea behind event is quite simple. Just as we have our commands, which we can think of users requests or internal services requests or external services requests. So someone or something can trigger a command, which is a request that we need to handle, and for example, process some internal business logic. Then we can also have events. And event means that something happened, right? So if my service says order created, that it means that it probably, not probably, that it actually created an order, and other services, it can be 0 to n services, can subscribe to this particular event and gather this knowledge and do something about it, right? And you
Yes.
can do whatever you can think of with this event internally.
Yeah. And one more thing, that's exactly what Piotr said, but it's kind of important to distinguish these two types of communication. When you're sending the command, in most cases you expecting that only one service will actually subscribe to this command, because as we said, since the command represents the user intention in the particular part of our service, in the particular part of our domain, then probably only one service will be responsible for processing this. And things are a little bit different when it comes to events, because when we are publishing an event, so we're kind of informing that something happened, like we created a discount, then there might be there's high chance that more than one service will actually subscribe for this particular message, because maybe in one microservice we will kick off some business logic that's related to the discounts, and in the other part we'll send an email for the customer that your discount has been granted or something. So we should distinguish these two types of communication.
Yeah, exactly. So let's try to create our event, right? So we have our command, create discount. So let's create an event. And within our messages directory, I will create another one. And let's just name it events, the same as we have for our comments before. And I will just create a new class similar to our create discount. And I will just call it discount created, right? Meaning that we have a new discount created within our discounts microservice. Okay, to get started, I'll just implement this iEvent. And again, iEvent service, or actually the interface, is a marker interface. It just means that this particular class is of type iEvent, right? It's nothing else.
Yes.
So this is this.
And this is
yeah.
once again, this is used just for generic constraints when it will come to publishing this. So nothing more but this. This is used just for the constraints.
Yeah. And what should we send within our event? That's always a good question. But we always need to think in terms of actually our message bus. So what we shouldn't send within our events are at first our internal domain objects, right? So we don't want to, for example, serialize our internal discount or order object and pass it, just send our internal domain to the message bus, because we don't want to expose our domain. That's one thing. And it also implies the fact that we don't want to send like really big objects, right? You can think of
Yeah.
maybe order, which can have multiple order items, customer details, and so on, payment details, a lot of things internally. And it might weight about, I don't know, a few hundreds kilobytes. And now imagine that you would like to send this event to the bus, and there will be multiple queues subscribing to this event. And if you start sending like tens or hundreds or thousands of events that are really big, then your queue, might become a bottleneck. It might get stuck.
Yeah.
So always try to send rather small objects.
I would say that this is the general rule of thumb. So just when it comes to the processing data in general across your microservices, you should only exchange data that's actually necessary for processing in other services.
Yeah,
It makes no sense to first expose the domain, as you said.
Yeah,
but also.
And yeah, in one of the future episodes, we'll show you how to deal with this because let's say that in some other service, you would like to maybe get this order details, but you don't want to send the order object in your event because it might be really big, right? So what you can do instead, maybe just send an order ID within your event, and then the service that is interested in getting these order details can execute a synchronous HTTP call to this order service and get the DTO internally within HTTP, right? Request. So that's how you deal with these situations. But like I said, in one of the future episodes, we'll go through this as it's also a little bit complex topic. But also one of our rule of thumbs is that whatever we have in our command, which is our original request, we also put it into our event. But if you want to put there more properties, we can easily extend it. But for most of these scenarios, we just copy and paste what we have within our command and put it into our event and maybe add a few more properties if we feel that it's required. So this is our simple event called discount created.
And one more thing, just before we move further, you should notice that this message is also immutable.
Yeah.
So the same thing that happened to the commands.
That's exactly what I wanted to say.
Okay, sorry.
Yeah, it's also immutable.
So we should not mutate this across microservices. We just this is even more important when it comes to events because, as Piotr said, event is represents something that happened. So if this happened, we should probably not mutate this at all. So that's a
fact.
That's a fact. So we should not change this. This should be purely immutable.
Yeah. So we have our structure. Now it's very easy to actually publish it into the message bus. We don't have to do anything special here because here we are only subscribing to the messages that we are interested in. We can go into our discount handler because usually within our command handlers, we will be publishing some other commands or events because this is where our logic happens, our business logic happens or is being orchestrated by some domain services. So let's just inject here iBus publisher like this. So this is our interface coming from the DShop common RabbitMQ namespace. And I can just call the following bus publisher and publish async. Send async is for comments and publishing is for publishing the facts. So this is for events. And I can just pass here a new event. So let's create a new discount created object. And let's put there our data. So we'll just pass here our data coming from the create discount command, which is the percentage as the last one parameter. And finally, we'll also pass this context. We'll talk about this context in one of the future episodes as well. So for now, just pass this correlation context as the second parameter within send async or publish async. And pretty much that's it. Right now, once we start our application one more time, it will start publishing these events. But now that's a good question. How can we subscribe to these events in the other services? So what do you think? Which service we should use to subscribe to this particular event?
To me, I don't know. We can pick orders.
Yeah.
Something.
Okay. Let's start with orders, and we'll do it in a very simple way without any specific business logic. We'll just show you how you can subscribe to these events.
Yeah, it makes some sense just
Yeah.
to demonstrate how this actually works.
So the first thing is that as it was with our API gateway, where we added our, it was here, where we added our comments, and there was the discounts, and we added this create discount command with this message namespace into our gateway. So we need to do the same for our order service, right? We have to like copy and
Yes.
paste the same structure. So let's create here a new class, and I'll just call it discount created.
Okay.
And I'll just copy and paste this one. And of course, remember, if you are using some flexible serialization, you can omit some fields. This is not a problem. If you are interested only in maybe this field, you can do it like this, right? And that's totally fine.
Yeah.
Okay, so this is our...
Yeah, publishing the event. You can publish as I would say as many fields or the properties in this case as you want, and this doesn't mean that each microservice that actually subscribe to this message will use every single field. So in order service we might use every property, but in the other customers, maybe we'll just need an ID. So
Yeah.
we can just cut this the other fields off, and that will be totally fine.
Yeah, exactly. So let's subscribe to our event. As you can see, I also added this message namespace because we need to specify that our discount created will live within these discounts, which will be translated to this routing key. Similar to this, we just discount and then discount created as the latest part
the same
of
story like that we discussed.
so
in
this
last
is
episodes.
this is just this routing key that we are using. And finally, I can grab this structure, and within my startup, I can put there actually anywhere just .subscribe event, and I will pass here my discount created event like this. Okay, we'll talk about these extensions also in one of future episodes, so don't worry about this for now. The easiest way to subscribe to event is just like this, just .subscribe event, pass the type, and that's it. Now, because our subscribe event will look for the event handler under the hood, as we've shown you in the latest episode, the same as it was for the subscribe command, where it looks using, it does search using service locator to the particular command handler. We also search for the particular event handler for this type. I will need to create a handler for this event, so I can just add it here like this. I can add a class. I think, all right, there is some, it was handlers.
Yep.
Yeah, so let's maybe put there another directory. If you have a lot of different handlers, you can put it into different directories which are dedicated to different services. It's your personal choice, as it usually is. So let's...
Shouldn't this be a class?
Yeah, right.
Yeah.
We have, okay, no more subdirectories. So just discount created handler. And similar to the command handler, we have...
So the same naming convention that you apply to command. So simply the name of the message plus the handler sub.
And the only difference is that we have event handler instead of the command handler. So, but the rest is pretty much the same. So
yeah, but the idea is the same. So basically, this is the class that actually knows how to deal with this type of message.
Yeah.
So actually kicks off some business logic inside this.
So let's see if it actually works at all. I can maybe inject the iLogger here of this type. And let's say we have our logger. And here I could do something like logger and maybe log info. And let's say discount created. And let's display our discount ID. Okay, and maybe let's return a task like this. Okay, so right now it should all work. So maybe let's give it a try, okay?
Yeah.
So I'll need to start a few services. I will start the API. So let's .NET run, or sorry, maybe the script will be faster. I will need to start the discount service. So again, the .NET run script. And finally, I'll need to start my order service. And also with the script. So API is up, discount service is up, and my order service should be up and running. Okay. There are some, this is the serial log, so you can see that the discounts or the order service subscribes to a lot of different messages. And this is, you can see this because we are using serial log. We'll also probably add this serial log in one of the episodes later on. So this is why you can see all these messages here. All right, so let's try to create a new discount. Here is my REST client with Visual Studio Code, this extension, and let's just call this again. All right,
promo free,
and let's send a request. So the request should be sent immediately. Yeah, the first call is always takes some time. And let's see. Let's at first check if our database actually has the data. So we have new data stored. And yeah, as you can see, our order service invoked the event handler. So we have this handling a message, which comes from our common interface. We have also logger here. Then it's our handler, discount created. So this is our logger information method within our discount created handler. And finally, we have this information that it was successfully handled, right? So as you can see,
basically,
yeah,
this works.
Yeah, it works. It works right away. Yeah, and we can do the same. For example, I can go maybe to my notification service, and also here I could do a handler similar to this one, like discount created, and then maybe send an email based on this discount that was created for this particular customer, right? So remember that you can subscribe. You use events, as an integration pattern between your services, which is asynchronous, and this is what you should always opt for asynchronous integrations, communication, and all these things. Okay, so what next? Maybe we could try to subscribe to some special event on
maybe
our discount service side.
See something more practical. I mean, something more fancy than logging stuff on a console.
Okay.
Yeah, so we can use the existing events that we already have in the project to get rid of this creation process. So how about doing the very simple thing? So let's say that we would like to validate whether the customer actually exists when we create the discount, because if you go to the discount, as you already have this step. So maybe you can go to the discount aggregate, or in this case this is more like entity, but so as you see, we have this customer ID field. So for now, when we get the data from the API, which actually publishes the command, we kind of need to believe that this customer ID actually belongs to some customer, right? We don't have any kind of validation that says, okay, this given customer ID does not belong to any customer we know in our system. So it would be cool to have some kind of validation here. So for this particular case, we could use the events as I would say, the synchronization mechanism between two microservices. So basically what we are going to do is, whenever we create a customer, we will publish the event, like, as you probably expect, customer created. And we will, in the discount microservice, we will subscribe to this event, and we will store our own, I would say, smaller implementation of the customer aggregate inside discounts. So for simplicity's sake, for now, we'll just need, ID, I think, right?
Yeah,
In a
I
customer.
think just ID for now.
Yeah. So we'll simply keep the customer inside discounts microservice. So then having this, we'll be able to create very simple validation for checking whether the given customer ID actually exists in our database.
Yeah.
So hopefully this is clear.
Yeah,
What
so
we're going
this
to
is
do.
this is how the validation might look like. So we get our create discount command, which holds the customer ID, and then we would like to have some customers repository, which will store, for example, in our internal database for this discount service, the customer's details, right? And if I need only customer ID, then I can store just a simple class with a single ID property within my database, and it will be enough for me, right? If I want to get more data, then I can, fetch more data.
And I think that and at this point we should actually cover one more thing, which you kind of discussed in a previous episode, which is that for some people this might be kind of weird that we keep customer inside the discounts. And why is that? I mean, I think that this is once again thing that you should not be afraid of redundant data in your microservice, because by doing this we kind of reduce the coupling between the services. So having this data inside the discounts, even though it's the customer, is in this case it's fine.
Yeah. So the reason why we are going to do this is very simple. When you are working with distributed apps, you want to have your apps, being independent from each other. And we are not talking about references or some packages. We are talking about not using the other apps, other services via internal HTTP calls, or use as less as possible internal HTTP calls. And the reason for that is because whenever you need to call some other service synchronously via HTTP, for example, there is this thing called temporal coupling. And we want to avoid it. We want to reduce it, because you can imagine, for example, the scenario where you want to create a discount, and at this time your customer service is currently offline, maybe because it's down, it died, or it's restarting, it's upgrading, whatever the reason is. And if you are going to make a synchronous HTTP call, it might fail even after a few retries, because there might be something wrong with this customer service. So instead, you want to keep this customer data within your particular microservice and just reuse it. So you don't have to call any external services internally or externally. You know that the customer is here because you receive this customer created event, and you know that it's a fact, right? So this is how you can add this resiliency to your microservices and reduce this temporal coupling and internal calls. So that's like the whole theory.
I'm not sure, but speaking of DDD, it's shared kernel, I believe.
Sorry?
Speaking of DDD, this concept is called shared kernel or something.
No, shared kernel would be more like sharing the domain objects. For example, you have bounded context A and B, and within context A and B, you are using, for example, the user entity, which is the same, so you can share the same class.
Oh yeah,
that's like it.
Yeah.
So
one more thing, in this case, stop using equals for nulls.
Correct.
7, you have.
You can easily you can overload the implicit operator, and the things might go wrong. So that's true. And also it looks much nicer, like you were writing a book. Customer is null or it's not null. So
So if you're using C#7, I believe, when the constant patterns came out, so you can easily use this.
Yeah, that's good.
Okay.
So no more talking about theory. Let's do some do some handler. All right. So what we need to do at first is, again, create a similar event on our service, within our service.
Yep.
So let's put there a new class, customer created, which will be iEvent class.
Book interface. Yeah. And that's also a good example that we kind of discussed a few minutes ago, that if you if you see at the customer created event that's kind of that is placed in the customer's microservice, you will see that this has way more properties. But in the discounts microservice, we actually need just an ID. So
Yeah.
in this case, we'll just simply we'll duplicate the type using the name, but
Yeah, but
will be much simpler.
at least for now, we only need the ID. But later on, who knows? Maybe we'll need more. We'll see. So let's start with this simple ID. We have the namespace, which is valid. And finally, we need to do this subscribe event for our customer created, like this. Okay. Now we need to create a handler. So let's create a new handler. And here, let's create a new directory. And I'll call it just customers. And the customer created handler. So the same story. I will implement IEvent handler of type customer created. And let's implement the members. And we can do it like this. So right now we are subscribing to this customer created event. We have the handler. And we probably need some sort of repository, right? Because we want to save this data somewhere. And we probably don't want to use caching for that. So let's create our repository.
I think that first we should start with the customer.
Oh yeah, itself. Right. We need to start with customer. So within our domain, I'll create a new customer, which will be extremely simple class. Just a single property for now, being our ID. We can do a get private set. And let's initialize it within our constructor.
I have no clue why Rider actually
puts these properties below
constructor first. Yeah, this is kind of weird to me.
Yeah, this is weird. But I also found latest a nice snippet. You can do something like constructor P, and it will create a new constructor with all of your properties. So CTR P, CTR P, yeah. You can do CTR for default, or you can do CTR like this.
That's awesome.
Yeah, I found it by accident, but it's pretty cool. CTR P, and it will create a constructor with all of your properties. So it's kind of cool.
Yeah, most of the cool stuff are pretty much found by the accident. So yeah.
Yeah, so CTR P is my new favorite.
Yeah.
Okay. So we have our customer, and now let's go into our customer created handler. So we need to have the repository. Yeah. So we need to inject here some repository, right? Like I did here, but I don't have it yet. So let's create a new repository. Customers repository. And let's put there at async for now for our customer object.
And once again, we could create some subfolders for the repository, so for the discounts and for the customers. But in this case, I don't think that makes sense, because this actually is responsible, for this actually interact with the domain object. So in this case, this is fine.
Yeah, it's totally fine. And we could have something like maybe exit async, but we'll just stick with get async because it's simpler. So we can do it like this. I can do my asyncs if I want to. And finally, I need to inject my CTR, my iMongo repository of T, where T is our domain object. And we need to put this identifiable, because we have this interface for our entities with their IDs. So here is our repository. And let's simply invoke it like this. So repository get async for our ID. And here, remove this. Repository add async our customer like this. Okay, we could basically remove this and just return a task here. So it will
In
be
this
even
case,
a little bit more performant. Should I do it like this?
Yeah.
Okay, let's.
Because in this way you will not
Yeah.
generate the
State machine.
Okay,
let's
state machine beneath.
let's look for optimization whenever it's possible.
Yeah.
All right, so here's our repository. Before we start using it, remember about one thing. It will be registered here by default for this call, but we need to explicitly say that we are adding a new repository. So I will say we have our customers Mongo repository registered here for this type.
By this, you're allowing this iMongo repository injection in your constructor.
You can register. You're just registering a repository for the specific type using this collection name for your database, just like we did for discounts.
Yes.
And yeah, finally, we can inject our repository. So here, let's put it there. And I could simply do like await and then add async new customer using my event ID, something like this, right? And that's pretty much all I need to do. And again, I could probably remove this by this.
Yeah, one-liners.
Cool. Okay, here we'll save our customer based on this customer created event that we are subscribing to here. And now let's reuse this information. So whenever I'll be trying to create a new discount, I'll also pass here my customer's repository. And here, like I did before, I will check if my customer exists, right? If it doesn't exist, I will somehow fail. So maybe for now, let's just try to do a return. Don't throw any exceptions here. We'll talk about failures also in one of the future episodes.
You could also maybe you could put some logging.
That
console right.
Yeah, that's what I wanted to do actually.
Okay, sorry.
Yeah, so let's see if it's gonna work. So let's put there a log.
And the reason for that is that we'll discuss the dealing with this type of situation. So we'll discuss not the happy paths in a future episode. So
not this one.
Keep calm, and we'll definitely go to this.
Yeah, so maybe here I can do something like logger. Maybe let's make it a warning. Customer with ID.
Now I see that we could actually create something more like
Command.
exists async, but it's
that's what I said. We could do this exists async,
but having this, we actually introduce this is pattern. So this is also cool.
So here is our customer log for our customer, and maybe also put this, and below is the previous code. So here we are sure that the customer actually exists, right here. We are certain.
We have our awesome validation.
Yeah. So maybe let's also put the logger here, so it will no longer be a one-liner, but we don't have any logging here. So maybe let's see if it's actually gonna
create a fluent API for this to have.
Or static. No, I was kidding. Okay. So I need to do this await here actually.
Yeah.
Okay, and let's do a logger, log information, customer with ID, or just created customer with ID, and our event ID like this. And that's pretty much it. We have our handler for customer created. We have our handler with validation for create discount. We have our repositories. Everything is set up properly. At least I think it is.
Yeah.
So let's try to test this scenario.
This is the 4th episode. I'm still waiting for the failure. Hopefully, maybe this time.
No, I hope not. All right, so let's.
But you need to rebuild the services, I believe.
That's also true. So I need to restart my discount service for sure. And I also need to start identity service and customer service, because right now I'll be actually creating a customer before I can create a discount. So here, let's go into my identity service. and let's start it. And let's also start my customer service. Okay, and in the meantime, I will remove all this data. So it's no longer some fake data. Okay, and let's see. So customer service is up and running,
So
and the
this is
identity is also up and running. Yeah.
I would say that we kind of start the fun part, because now it's for simple validation
It's 5 services
we
already.
actually yeah, we have 5 services, and that's awesome.
Yeah. All right. So right now, I will copy this for now, and let's open our API and our discount. Sorry, the DShop REST. This one.
Yeah.
I'll just put it here below. Okay. And it was the API URL. Okay. So let's put it there. And now, okay,
Yeah.
let's maybe start. Let's try to create our discount without our customer existing. So I'll just send a request, and let's see what happened. So we can see that we handled this message, but we got this info that customer with ID wasn't found. Okay.
Yeah.
So it's working. It's working in a way that our validation is fine. It got here and returned. Okay. So let's get back into our REST definition, and let's go through this flow. So I will scroll down a bit to the user workflow, and let's create a new user. So I will send this request to the sign up. Come on. Okay. If I try to sign up again, I should get an error, so it's fine. I think I did some mistake. Let's see. Maybe I'll just not this. Let me remove it, because I think I accidentally clicked this a few times at once, and we don't really have an index or our username like we would in our SQL server. I didn't put an index on the username in our MongoDB, so I think I just clicked this a few times and it created few users somehow. So let's do it once again.
Here's the fail I was waiting for.
Yeah.
Yeah, you failed this.
I really wanted to do it fast, but okay, let's do it one more time. Okay, let's get our access token. Put it there.
Yeah, so we simply need to create the identity that will next connect to the customer. So.
Exactly. So once I have my access token, I can go to this post customers, and I'll create my customer account.
Yeah.
So let's see. Let's see what happened. Yeah, nice. So here's our discount service, and as you can see, it handled the customer created event, and it created a customer, right? So that's cool. We can see that here, if I refresh it, our discount service will have another collection called customers, and here's our very simple object, having only the ID, nothing else. So let's try to complete our create discount flow. Right now I can take this ID, so I could basically grab this ID here, and let's put it there, and let's call it promo and send a request, and let's check our logs again. Let's see, customer created, create discount, handle message, no warning. So it seems that actually it worked just fine. And if I open my discounts, you can see that there is my discounts, object, new discount object. So everything.
So basically, the validation passed, and we're happy.
Yeah. And this is how you can, and you probably should in most of the cases, do this integration between your services. So, of course, you could, for example, here do something like customer or customer DTO, and then call some HTTP client like this, get a sync, and call your customer service to get this, right? But if you start doing it, then like we said before, it may happen that your customer service that you are trying to call via HTTP request, which is synchronous, it may be temporarily down or not responding to your request, and then it will just fail, right? So by doing this
Yeah.
asynchronous integration using events and these event handlers amongst different microservices, and just keeping your own internal data that can look very different than the original data in the microservice that originated this particular event, you will get this resiliency. You'll get a lot of resiliency because the data is here in your service that actually needs it at this time. So it will just ask its own internal database. It will not ask the external service to get this customer. So as long as this service is up and running, the customer service might be down, but your discount will still be created without any issues. And this is one of these integration patterns. But it basically comes from the domain-driven design world. Once you start thinking about this as bounded context, and once you start reading about these events, you will quickly find out that this is just an integration pattern using the events. It's not like a magic for microservices. It's been there for many years now, so it's nothing really that's special. So
I think that this is it for this episode.
Yeah,
I don't know.
Yeah, this is the basic stuff that you can do with events. And as you can see, for now we have pretty simple scenario. We have single command producing single event, and that's the whole flow. And for some of the applications, maybe some simple applications like sort of CRUD applications, it might be it. But there are cases when you have a lot of things, a lot of messages going on, starting from single request, single command, and there might be like few or tens events being exchanged for this whole process. And we'll also talk about how to deal with this in one of the later episodes. So this is going to be a lot of fun, for sure.
Yeah.
But
if you didn't realize, that was the kind of easy scenario for dealing with this message exchanging. So we'll definitely have more fun in the next episodes.
It's like you just started learning a C# language, maybe, or some other language, and you learned what is a method, like how to create a method and how to pass arguments. And then a few days later, you start learning about lambda expression trees. So this is like where we are heading one of the future episodes through this comparison. So yeah, that's it for today. And
I think that since this is the last episode in the 2019, I think that we should wish you a happy new year.
Yeah, we wish you happy new year, and hopefully we'll finish the series in the next year. We have a lot of time.
Yeah, we have 1 year for finishing this, so we'll see. That's a challenge, I would say. No.
Okay.
But that was a question. Oh, one more thing. Yep. I think that more for the guys who actually watching this. If you have any specific questions, then you can put there. We have actually 3 places for collecting this kind of questions.
Yeah.
Or maybe 4. So we can you can ask the question on the YouTube, but there might be a chance that we'll not be as quick with our answers.
Yeah, so
as we would like to.
You can put it there, but
the preferred way is Gitter, either Gitter or our forum.
Yeah, so there are 2 preferred ways besides YouTube. Try to put it on our forum here, there is a link for forum.devmentors.io, or try to put it here into our Gitter. As you can see, there are already some people asking some questions, so there is something going on here. So either forum, Gitter, or YouTube.
Yeah. Yes. Maybe we'll collect some questions. Maybe we'll just create some short Q&A.
Yeah. I mean, at some point we'll
have some issues or something.
Yeah, we need to create some documentation at some point. But for now, we are just collecting some questions.
Avoiding this.
Yeah, avoiding this. Okay.
Yeah. So once again, happy New Year. Hopefully, yeah, just get rid of bugs and this stuff. Hopefully, you'll have fun with us in 2019. Hopefully, you will learn something new, something awesome. Hopefully, we'll finish this series.
Yeah, we will.
Yeah.
Okay. Thank you and
Yeah.
see you next time. Bye.
Yeah. See ya.